Thermal insulation, discussed in Chapter 5, controls only the flow of energy through a building envelope, and energy flow is only one of the several environmental factors that must be controlled in the design of a building envelope. The other important environmental factors intimately related to energy are air, water vapor, and liquid water. In this chapter, we will focus on air and water vapor control. Issues related to water infiltration control are covered in chapters 27 and chapters 28 and 29. Outside air often contains dust, pollen, ozone, and other pollutants. Inside air is typically subjected to mechanical conditioning. It's heated, cooled, humidified, dehumidified, and filtered. The unregulated flow of outside air into the interior not only introduces pollutants, but also increases energy consumption because the outside air entering the envelope, uncontrolled, is not subjected to such conditioning. The entry and exit of such air is called air infiltration and exfiltration. They take place through cracks, gaps, voids, unsealed joints, and at the interface between envelope assemblies. Water and water vapor, collectively called moisture, are essentially the same material but in different states. Water is a liquid and water vapor is a gas. Water vapor generally occurs in combination with air. The leakage of air through the envelope is therefore always accompanied by leakage of water vapor. The movement of water vapor through the envelope assembly can cause significant problems if it converts to liquid. Water wets the infestation, creates dampness, giving rise to mold and fungi, peels off paints, and reduces the strength of cellulose and gypsum board or gypsum-based materials. Controlling water vapor flow in order to prevent its condensation within the envelope is therefore critical. A great example of the difference between leakage and diffusion can be used with a balloon example, per figure 6.1 on page 146. Diffusion occurs through the material, while leakage takes place at a joint where the material is not continuous. The best way to control air and water vapor is to reduce air leakage in the building envelope. Two factors that affect air leakage in a building are the leakage area and the pressure difference between the inside and the outside air, caused by wind and temperature. Air infiltration and exfiltration through a building caused by the pressure difference created by wind. Because wind creates positive pressure on the windward face of a building and suction, that is, negative pressure on the other faces, air infiltration and exfiltration occur. Another factor that affects inside-outside air pressure difference is the difference between the inside and the outside air temperatures. Because the density of the air increases with decreasing temperature, cool, more dense air exerts higher pressure than warm, less dense air. Thus, during the cooling season, cool inside air has a higher pressure than warm air outside. This leads to continuous exfiltration of cool air and infiltration of warm outside air through the envelope. During the heating season, the process is reversed. Let's take a look at air and water vapor control and air diffusion control. In addition to controlling air leakage through the envelope using sealants, gaskets, and weather stripping, we also need to reduce air diffusion through the envelope's materials. This is achieved by using an air barrier in the envelope. Because an air diffusion barrier must allow water vapor to pass through it, it cannot entirely be impermeable to air. Therefore, it's not really an air barrier, but a retarder. Figure 6.6 on page 148 illustrates typical leakage sites in a wood frame or light gauge steel frame building. Notice that most leakage sites in the building are in the walls. It's important to note that there are two separate layers. There's a vapor retarder that's placed on the inside of the stud wall, on the inside face, and this vapor retarder is typically a sheet of plastic that gets stapled up onto the studs, and then the drywall is installed on top of that, and the air retarder is on the outside of the building. So the air retarder gets installed directly on top of the wall sheeting, and in this case it's important to note that furring strips are placed directly on top of the air retarder, and the siding is fastened to those furring strips. That allows for a continuous drainage layer behind the siding. That allows for any kind of moisture that gets behind the siding to completely dry out. This is an image of Tyvek, a product called Tyvek. It's an air barrier, and it's during the installation. So you can see that this is basically a wrap that comes in the form of a roll. It's rolled out over the outside of the sheathing, and it's attached to the sheathing. Now every joint in this material has to be taped, and you can really barely see this, but since these sheets cannot be continuous all the way up the side of larger structures, there are joints that have to be taped. And so the manufacturer Tyvek provides its own proprietary type of joint tape that goes with its own system. An air barrier consists of either a sheet membrane or a liquid applied film. The membrane or film is applied on the outside face of the exterior wall, immediately behind the exterior cladding. Therefore, an air barrier is required to perform the following three functions: air permeability, water resistivity, and vapor permeability. Take a close look at page 149 in your text. To reduce air diffusion and leakage as much as possible, a continuous air barrier must be used, as seen in the photograph herein. But wherever we have penetrations in the facade or the exterior walls, like doors and windows, we also have to tape each of those items. So in this case, we have a window with a flange. The flange gets nailed to the structure, and at this point we have a joint where air leakage can occur. So what we're doing here is we're just applying a self-adhering window, self-adhering tape at each one of the flanges, continuous all the way around the opening. This is the end of Chapter 6, Part 1. Now it's time to take the quiz for this section.